Okay, is my screen visible?
Yes, yes, it is visible.
Okay, so let me just do a recap before we start today's session. So, on the first day of the supply chain session, basically we have started with the introduction of supply chain management. We have seen some case studies as well and seen like how a linear supply chain looks like, how a multiple, like a complex network supply chain looks like, why supply chain is important. And we have seen some case studies of Toyota, just in time, Zara, like who have leveraged a very advanced supply chain and kind of doing the demand forecasting and inventory control. Walmart, Amazon. So we have seen certain case studies, and also we have seen some failures, like where due to the like improper or ineffective supply chain, the business has failed. What is quality control? We have seen. Then the aspects of quality control, product lifecycle management, like how the product lifecycle can be traced starting from the production to the consumers. What are the different enablers of supply chain? Like we have seen that there are three different enablers that are product and money. Different types of supply chain analytics. We will come to this slide again today. So, like little bit advanced, we will study today. Role of supply chain analytics, like what are the different roles in demand forecasting, inventory optimization, and there are certain other roles. And also, we have seen some demand in kind of a PLM software nowadays. So we have seen like the recent market, like how it is, like it is growing in 8.0% CAGR. And so by 2020-30, we can see a major, like surcharge in the demand in the PLM software. So we have done some Monte Carlo simulation also, simulating the demands based on the random probabilities, and we have simulated and seen that how we can optimize the demands and the cost, our operating income on based on those demands. And also we have seen that certain other factors which you can basically derive from the simulation, like building the similar simulation. So these are the formulas, certain formulas I had given, which can be actually leveraged, like which actually can be derived leveraging the same simulations. Okay, so today is day one. So day zero, I have completed like what we have kind of done a recap on the like the topics which we have covered. So today we will learn how what is digital twin, why digital twin is so important in supply chain. Okay, what are the different factors of digital twin? Basically, like the enablers, where the data is coming from to build a digital twin, how we can build a digital twin, fundamentals of supply chain optimization as well. We will study and defining and building a sample optimization model. So this will be interesting. I will take any questions at the end of the session. Okay, so just note down the questions if you have any. I will take the questions at the end of the session. Okay. So what is a digital twin? So by definition, a digital twin is a virtual representation of a physical object, system, or process. It mimics the real world entity in terms of its attributes, behavior, and interaction, usually created during using data from sensors, IoT devices, and other sources, along with advanced modeling and simulation techniques. So basically, a digital twin is we can say, a virtual representation of any real time, real world object, like a physical object or a system or a process. So let's understand like deeper into this topic. So we have some different types of digital twins in supply chain, like in the context of supply chain and operations. And the complexity to build such digital twin, like I have given this complexity level. So it starts from low, like from product, it starts with a very low complexity level. Like if we want to build a digital twin of a product itself, and then process, then company level, then supply chain network level, then network level. So till we reach the network level, the complexity goes very high. Okay, so first let's start with the product. So what is product level digital twin? So if you understand it more or take an example, so it's a kind of a digital twin of a high-end, let's say the example is digital twin of a high-end smartphone model. Okay, so The digital twin collects data on the phone's parts, assemblies, components, logistics. It helps predict potential failures, allows manufacturer to monitor the product's condition, performance, and provides real-time insights into inventory levels, stockouts in retail points. So this is an example like where you can actually create a digital twin of a real-world product. Now let's say what is the next process, like the next digital twin. So it is a process level digital twin. So let's see what it is. So process level digital twin is actually, you can take an example of, let's say, a digital twin of an order fulfillment process, wherein you simulate order fulfillment process by analyzing the bottlenecks, predict delays, and suggest optimization, such as adjusting 1 minute. Okay. Oh, yes. Sorry. So basically, let me go to the current slide. Okay, so I was explaining the process level digital twin. So process level digital twin means like you are simulating, let's say, order fulfillment process where you are analyzing the bottlenecks, delays. You are suggesting some optimization such as adjusting stuffing or reconfiguring the warehouse layouts. So this helps reduce the real time and improves order accuracy and enhances customer satisfaction by ensuring timely delivery. So this complexity level is little bit higher than the product because it is not only like dealing with one product but also kind of with the process like the entire like a, let's say, a manufacturing process. So it is kind of creating a twin of the entire process basically. Okay, so let's say the other digital twin. So if we talk about company level digital twin, so company level digital twin, let's say an example of a digital twin of a warehouse facility, or let's say an inventory house, or a distribution channel. So it can be any entity where you can build a digital twin of the same entity basically. And it will help you in what? It will give you a holistic view of the warehouse, tracking real-time inventory levels, equipment health, and the workers' movements. So again, the complexity will be little higher than the product and the process to build a digital twin at a company level. Okay, then let's say it's a supply chain network level digital twin. So let's take an example of automotive supply chain. So here also you can see like the ecosystem of basically the material flows, the supply reliability, inventory levels, lead time, and the supply chain network. So kind of this, like as like the ecosystem is growing. Let me just admit. So basically, as the ecosystem is growing, so the complexity is also, like it is kind of going more complex than just building a digital twin of a product or a process on a company level. Supply chain is even more kind of, it's a full ecosystem of the network, basically of the manufacturers, distributors, retailers. So building an ecosystem or the digital twin of this ecosystem will be little more complex. Okay, so let's say, so I explained that about the supply chain. The last one I explained is supply chain network level digital twin. Okay, anyone else will join? Just ask that whether anyone is joining, then I will just take them at once because it is like disturbing the session.
Yeah, till then, may I ask a few questions?
Yeah.
So, the all this will lead to a supply chain management system. So, I've seen on internet, Walmart has implemented it, and Amazon is also trying to implement it in US. So, my question is this product a luxury product or an essential product for the customer?
No, it is an essential product nowadays. Why? I will tell you the reason. Because as the ecosystem is building, like the network of the different distributors, suppliers, and even it is like increasing globally. It is not in as a like centralized in only one place. So if you talk about Amazon in US, Amazon in US has a like the global, basically the system built on the distributors, suppliers, manufacturers, end users like the customers. So the ecosystem is very very complex. So it is not a luxury of like a luxury thing which you can implement nowadays. It is an essential thing, because otherwise you won't be able to take certain decisions based on your like demand forecasting, your inventory management, how to like taking the decision on the routes, like how you will like transport, what will be your optimized cost of transportation. So I will give you an example. I have taken an example, a case study, like where we are calculating a optimization model on transportation cost. So all these factors are very very important for a company to really sustain in the long run, until and unless it has a very effective supply chain and logistics system.
Okay, so like it is essential for the business to grow its operations.
Definitely, yes.
Okay. And I had one more question. Like in terms of digital twin, what challenges we are facing in like implementing in real time,
There
practical
can be,
implementation?
see, there can be challenges like like basically when you are building a digital twin. So how you are building it? You are building on terms of the data, right? So sometimes the
Right.
data will be available when where you have like your in-house data. So basically, you're like say suppose you are building a twin of a product. So product data you can like we build a digital twin taking the data from the like CAD software, CAM software. Have you heard the names of like
Yes,
computer aided design, computer aided manufacturing? So from there you can actually take the data and build a twin on the product. Even for the process, like if the data is available in your company itself, then building a ecosystem or a digital twin on that won't be a challenging part. But let's say if you are basically pulling the data from the external sources, so basically like the logistics or the distributors or the like the other like the warehouses, inventories, inventory, like the management warehouses and all, where you are pulling the data and they are not the part of your company, and kind of you are kind of pulling the data from the external resources, as well as it can be the real time data, that is like you can take the example of weather data, route condition, the shipment condition, the conditions which are not in your hands. Specifically, let's say if there is any like any storm is coming, for that like there are certain like government regulations which are put into the system. So it is kind of a real time data which you have to pull in and you have to do the analytics. There, I think certain challenges can come in how you are pipelining those data and what is the frequency of those data, like you are pipelining and building kind of the data lake or the data factory.
okay. So right now, for it depends on particular case in which if we have ample amount of data, we can build it.
Right. So if you say if your company's like the data is very easily available from your company's ERP system, your company's manufacturing system, your company's like the product development, like the CAD CAM software, your IoT sensors are working, which are actually transmitting the physical data into the digital world. So all these things, if you are pulling the data, that is fine. But something which is coming real time, such as I said, like you don't have the control over, like say like government has put some regulations, okay, like on the shipment or something, or like some new market conditions or the financial market conditions has come into place. So those things should come as a real time data, right? And you don't have much like control on those data.
Right, right. Thanks, I got it.
So okay, so I just explained till here. So these are the different types of digital twin in the context of supply chain and operation. So we have explained product, process, company level, supply chain network, and bigger the ecosystem is actually like getting higher. The complexity level is also getting higher. So it is the bigger the ecosystem, higher is the complexity level. So network of network means again that it is a global distribution channel. So you can think of an example of digital twin of a global pharmaceutical distribution ecosystem. So wherein you have multiple people like the entities like manufacturers, distributors, retailers, healthcare providers globally, like you talk about Amazon now. So like this kind of ecosystem, you need very advanced analytics, very advanced digital twin facilities to like to take certain decisions, to understand the flow of the information in the multiple networks. So this is kind of even a very complex thing. So building a digital twin at this level will be complex, but definitely it is a much needed factor in nowadays, because lots of decisions are taken on your digital twin, like simulating the data, and actually you can visualize that what is actually happening in your supply chain. So you can visualize that in the digital system. So it is giving you a control room where you can control many things basically. Any questions so far?
No, it's clear.
Okay, so let's go forward. So what is a digital twin enabler? As we have seen in our last session, that mainly we talked about the flow of data, flow of product. Definitely, there should be a product which is like moving, and flow of the money. Of course, the money is involved. Okay, so now let's. The first enabler is data. So when you are like building a basically a virtual system for a real world system, you need data. So data at the product level, it can come from your softwares, various softwares where you are building your or manufacturing your product. For the manufacturing system, or the like the basically when you talk about the process, it can come from your manufacturing process, which is called as MES, manufacturing execution system. For the company level data, it can come from your ERP, any ERP which is like the company is maintaining. It can be SAP or Oracle or any ERP system. So in ERP's full form is enterprise resource planning. So it is a kind of a comprehensive system which is maintaining all the entity level data at the company. So so these data can be taken from the company level, from the ERP system, and from the supply chain level, any external sources like logistics service providers, any real-time data like weather data, financial market data, any government regulations data, like I mentioned. So those data can be pulled for the supply chain level, at the supply chain level of digital twin. Now having said so about the data, what are the other enablers which are also acting parallel? That is a or the technology enabler basically. So we talk about IoT sensors. IoT sensors are nothing but the devices which are actually transmitting the real data into the virtual world or the digital world. Blockchain, we have actually like if blockchain can be integrated with digital twin, or digital twin supported by blockchain can have that traceability management at place. Basically it can trace the product from where the like raw materials have come from, even the finance components have come from, where it is assembled, where the quality has been done. So entire like it can give the product life cycle management. So entire traceability it can give. AI/ML algorithms. Now, when I talk about AI/ML algorithms, it is very important. Why? Because it will give you a better decision support system. So, digital twin is not about like visualizing that what is happening in real world. It is also about taking lots of decision. Decision regarding what? Decision regarding your demand management, like how you will manage your demand, how you can control your cost, transportation cost, like optimize your cost, how you can optimize your routes of the like logistics, then how you can optimize your inventory. There is always concepts of overstock and understock, so it should not be both, actually it should be optimized. So all these decisions can be actually taken based on the very advanced AI/ML algorithms. Okay, and of course there is a cloud which is involved, because when we talk about data, when we talk about all these sensors and the integration of all these platforms, so kind of there should be a cloud facility builder wherein you can integrate all these systems together to have a better operation. So these are the different technology enablers for building a digital grid. Any questions so far? Okay, so let's move on to the next slide. So this will be very interesting. So let's like I have taken an example. Like say this is a physical supply chain of a manufacturing unit. Let's say they have the manufacturing unit built at Bangalore and Kochi. From this manufacturing units, they are producing the like some units, like some products, components, and they are distributing it to the distribution channels. So distribution channels are located in Mysore, Salem, and Madurai. So they are actually sending these products to these distribution channels, and from where it is getting distributed to the customers or the end users. Uh, let's say the end users are located at Bangalore, Chennai, Coimbatore, and Thiruvananthapuram. So now you have like a big data regarding your entire supply chain network. Now, how difficult it to see in terms of, like if I tell you, okay, we have the, like we are maintaining a Excel wherein you can see a tabular data that, okay, your manufacturing units are here, 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 here. You can check the name of the places, as well as you can see the distribution channels, like where they are located, as well as you can see where your customers are located. Now, this kind of system will not be, like too much, what I say, like it won't be giving you much insight if I put everything in a map and show you like this. So if I show you, like, see, my manufacturing unit is actually in um, Mangalore and Kochi. So, like I said, Mangalore and Kochi. The distribution units are at Mysore, Salem, and Madurai. And my end users are located in Bangalore, Chennai, and Coimbatore, and of course, Thiruvananthapuram. Okay, so you can, from the visual impact, you can know, okay, these are the places where, like the locations are like the locations of the manufacturing units, where are the locations of the distributing units, and where the customers are situated. And probably, like you can also check, like if the data is there, you can also, like this kind of visualization can be drawn. Suppose the route is also drawn here. Suppose from Mangalore to Bangalore, this is the, like, sorry, from Mangalore to Mysore, I will delete this. So from Bangalore to, it is going to the distribution channel, say Mysore. So this is a route of it. And I am just showing it like just an example. But by the data, you know that this is a real-time route which is getting displayed on. From Bangalore to, let's say, Salem. And let's say from Bangalore to Madurai, it is going by this channel. Okay. So just like a, like just a diagram. But if you see that how the data or how the product is moving basically, like on the virtual system, then it will be kind of giving you a visual benefits. Not only that, you can understand that what can be your optimized location for a distribution channel to be for this kind of, for this region of your manufacturing unit. So this region means, I mean to say that, let's say for South India you're talking about. So when you're seeing that your manufacturing units are in two places, Mangalore and Kochi, you will obviously having some kind of visual connection that, okay, like my product is flowing from this factory to this channel, and then from this customer. So it is kind of giving you a visual, basically a visual system where you can understand that what the how is the movement happening. Now, is it so? Like, is digital twin is just a digital or a visualization, like a visual representation? It is not exactly so. Apart from the visual representation, what more we can have here is we can have a decision making support. So that is what I talked about in the last slide. So it is not only giving a visualization of the product, process, supply chain network, but also it is actually integrating lots of tools, lots of other tools. Basically, the company's ERP system, where the data is flowing in, any IoT sensors which are there in the trucks, like the, like measuring the humidity, temperature, or any other, like any other IoT sensors which are maintained in the warehouses for different products. There is a cloud facility definitely, and the blockchain kind of, it is supported by blockchain to check the traceability of the entire ecosystem. Now, having said so, digital twin is also about taking the proper decision support. Now, this I explained in my last session, like how you can actually take proper decisions with the use of analytics. And analytics, when we talk about analytics, it means a lots of data from different sources. So let's view that slide once again. Just one minute. Okay, so different types of supply chain analytics I talked about in my last session, where where we have the descriptive analytics. Definitely, we have the historical data, and we know that how the events have happened. Basically, we have the data that how the movement has happened, where the demand was, like in which month, what was the demand of that particular location. So everything actually we have this data available, historical data from where we can draw some analytics. Okay, we can diagnose also like why this has happened. maybe there was some national holiday, and that's why the sales has jumped, the demand has jumped basically. So basically you can diagnose lots of things based on the data. You can predict like what can happen next. So more we are moving, like to the advanced analytics, more we are going from reactive to the proactive thing. Basically, even the things are happening, we can actually tell that what is going to happen. So more we are actually going from reactive to proactive things. So predictive analytics comes into picture here, wherein you can actually predict that what will happen next. Or let's say a national holiday is coming. So in a national holidays, definitely you can predict that okay, the demands might be increasing. So you can actually take better decision based on those kind of forecasts to keep your inventory ready. So all these things matters for a like a demand management system or a building a supply chain ecosystem basically. And also prescriptive, like you can actually prescribe something, like what should you do, like if this is happening, like anything happening, what should you do, whether you are like controlling your inventory or uh, increasing your inventory, or you are decreasing your inventory, you are fully taking out the inventory, like what is the decision, like what is the recommendation which is coming from the system. So all these analytics you can do, and it is a very advanced analytics system where you can take the decision at various levels. It is not only at one point, but at various levels you can take, like the minute decisions, and that can actually build an effective supply chain in the long run. Okay, any questions so far? Okay. So these are the advantages of a digital twin in supply chain. So we have first one as enhanced visibility and real-time tracking. So already we have seen that like it allows the real-time tracking of the inventory, shipments, and assets. And also this visibility helps businesses to respond faster to the issues like shipment delays, any stock outs, or the demand surges by enabling more agile decision making. Then there is productive maintenance and asset optimization. So basically, like you can build digital twins or the replicas of your equipments and assets, so you can understand the like the better like the maintenance ecosystem, like where the product is varying or tearing, the usage patterns, the environmental conditions. So this kind of like predictive maintenance decision you can take on your assets. Demand forecasting and inventory optimization. So definitely I talked about like where you can like using the real time analytics, where you can actually forecast your sales, also the economic trends. Okay, you can optimize your inventory level across the distribution centers. I talked about understock and overstock, so we need to avoid that and keep that stock always optimized at the optimized level to reduce our inventory cost, as well as like inventory maintenance cost or management cost, as well as the transportation cost. So enhanced scenario planning and risk management. Definitely, like when we talk about what if scenarios, like say like to access how different factors like demand spikes or the supplies issue or geographical events might impact your supply chain. So these kind of capabilities can help companies proactively develop risk mitigation. I think the action plans or the action items, ensuring supply chain resilience in the face of disruption. Faster and more effective decision making. Definitely, when you have the data all in place and you have a digital twin built in, you have that full control room. Then your decision making process is much faster, and you can take effective decisions. Basically, depending on various factors, but you can take effective decisions. Enhance collaboration and communication. Definitely, like like it will be improving, because when you can talk collaborate with multiple like the suppliers and the products, like the production units and all, you can actually take better decision on the demand forecasting and the inventory control or the inventory management. So again, this is one of the point. Then better customer experience and service level. Definitely so, because your customer turnaround rate will be much reduced, right? You can like go back to the customer, answer their queries much faster, and even you can inform the customer like on the like the latest decision taken, like whether there is any delays in the shipment or in the like the inventory is not present. So you can inform the customer in the like on the time, so that like the you have the like the better customer, the customer have the better experience, right? So cost savings through process optimization. definitely like lots of decisions taken only to save the cost. Your cost savings will be definitely when we talk about in supply chain, why we are doing all these things, like why we are understanding that better, to operate in a more optimized way so that we have a understock and the overstock cost. So this kind of cost we are saving here. Scalability and flexibility, definitely, like when you have a digital twin built in, you have the better like flexibility and to understand that where are the different things happening, how the movements are happening, and I can actually like scale up your business to another location, or you can take some decisions that okay, do you need even a say distribution channel in this area. So all this kind of scalability decisions also like will be better with the digital twin. Enhanced traceability with blockchain integration, definitely, like I have talked that if your digital twin is supported by blockchain, then you have the entire traceability in place right from the product building, like from where the different parts are coming, the raw material is coming, till the it is reaching the end users. There will be the end-to-end products life cycle management which can be tracked in the blockchain. Any questions?
Yeah, I have one question.
Yeah, Hari.
As like businesses are segregated into multiple in terms of their market capitalization, like MSME, big enterprises. So it has like use cases for Discipline has use cases for the enterprise businesses. It does it also have like use cases for small scale businesses which operate in certain state or in a certain sector,
So it depends basically. Let's say if you are talking about a kirana shop, right? So a kirana shop, which is like only distributing the let's say the products or the whatever they are keeping some like monthly things. So whatever the things are there, they are distributing in a very small area. Let's say within kind of 2 kilometer radius they are distributing. So definitely, I don't think that they won't go and like build a digital twin on their like the logistic part, because sometimes it happens like they will do it in a very locally, like they will just take the local operations and just deliver the good. So digital twins come into play when it is very, very difficult for you to basically track the data. I mean to say that when your data is so big that it is very difficult for you to actually understand that how you will do your inventory, what is like how you will do your demand forecasting, like like what will be the your route decision or to optimize your transportation cost. So basically there are like things which you have to think about, like when you talk about the small business, like what is the operation of the business in the terms of logistics, right? Then you have to think about whether it is kind of suitable to build a digital twin or not. So if the operation is, like even it is kind of, like dealing with two distribution channels and multiple, it is distributing to multiple, like let's say at least five kind of end user, then it is kind of obvious that you need those data into place and you need to take decisions on the demands and all. So definitely it's a decision where the company has to take. If the operation is there, the supply chain they are managing, they have a logistic system in place, then this is something they have to build.
yeah, like I have two scenarios in mind. One of which is like jewelry franchise. So suppose that there is a business person who owns five, six jewelry shops in different cities, or might be a shop where vehicle shops where he has the franchise in five, six cities. So this might be useful for them,
Right, because see, if the logistics is there, they are having a supply chain network, then
right?
this will be very much advantageous for them.
Yeah, I
So
got
it
it.
is. It can be jewelry shop. It can be automobile. Like a automobile. Basically, the retailer or the wholesaler. whatever. But if the logistic is there, that they are doing some supplies, even if for the automobile, it is very, very important because they have to do their demand and inventory, like, because if you are keeping the stock like over the, like if you are keeping, let's say the overstock condition. So if you are keeping things which is beyond the demand, like if you are just keeping it in the inventory. So lots of cost is associated with your inventory management, right? So if you're keeping the cars maybe in a warehouse or somewhere, you have to keep, like optimum conditions there because those are new cars or old cars, or you can say second hand cars. But you have to, like give the rent, you have to pay the electricity bill, kind of, you have to take a bigger space for keeping the cars. So your cost is, like actually kind of not optimized there, right? So basically, if you keep the exact amount of, like the exact quantity of the cars which is in demand, then your cost is lot being optimized over there.
Yeah, yeah, I understand it.
Okay. So let's do a case study. This is little bit will be interesting and try to understand this. I don't know whether you guys have read about optimization model, but if you haven't, then I will just, like maybe keep another session for just to explain the optimization model. There are different kinds of optimization model, but let's take a simple one. Okay, so we will do a greenfield analysis here. So greenfield analysis is a strategic planning approach used in supply chain management to determine the optimal location for new facilities. I already said that it helps in scalability and also kind of scaling up your business. So if you want to set up your new facility such as distribution center, warehouse, or manufacturing plants. So unlike other location analysis that might evaluate existing sites, a greenfield analysis starts from scratch, hence greenfield, and considers a range of potential sites based solely on the factors like demand, transportation cost, and proximity to market or suppliers. So when you do a greenfield analysis, it is basically says that you are not setting up a distribution center just like that. You are doing this analysis based on lots of, like it's a calculated decision basically. You are taking a decision based on lots of factors. Like your decision is backed by the data. The data here is like can be the factors like demand, it can be transportation cost, it can be the proximity to the market or suppliers. Okay, so from where that there you are actually doing an analysis and you are setting up your new facility. Okay, now when this is the kind of analysis, so let's take a case study example. So there are four key marketplaces of a manufacturing company in southern India. Okay, let's say a pharmaceutical company or any other manufacturing company where demand is given. So a demand is given basically. We will see the demand in the tabular format later in the later slides. So a demand is given. The manufacturing company has four key marketplaces. That means the four key customers basically we can say. The goal is to identify an optimal location for a distribution center. Okay, we call it as DC that minimizes logistic and transportation cost. So you have to like they want to set up a DC, basically a new facility wherein they can easily transport goods to the four key marketplaces and with the optimum transportation cost. Okay, so the model should actually determine the distance between the DC location and the other location in such a way that your transportation cost is the minimum. Okay, so that is what it means by the optimal location. Okay, so let's say the data. So the data for this greenfield analysis is given as, like you can see, there are four marketplaces: Bangalore, Chennai, Coimbatore, and Kochi, and the demands are given in units. Say 15,000. Like this is a monthly demand. So 15,000 units, 12,000 for Chennai, Coimbatore 8,000, and Kochi 7,000. And even their latitude longitude is given. So where this marketplace are actually located, the latitude is given for Bangalore, for Chennai, for Coimbatore, and for Kochi. And also what is given transportation cost per unit per kilometer. Okay. So per unit per kilometer, what is the transportation cost in rupees? That is 2 rupees in Bangalore, 2.2 rupees in Chennai, 2 rupees in Coimbatore, and 2.3 rupees in Kochi. So this is your data which is there. Okay. Now, there are certain, like the definition given, what is a marketplace, a city or region with demands for products. So basically, this is a market like the customers, you can say, who have actually created the demand for the product. Demand units means number of units required at each marketplace, indicating the demand size. Latitude and longitude, this is geographical coordinates, x and y coordinates basically. Transportation cost per unit is cost incurred to transport 1 unit per kilometer. Okay, which varies based on the distance and road condition to each marketplace. Any questions till here? Okay, so let's go ahead. Okay, now see, I have actually, like placed this data, whatever data is given on the map. So they have to have a, like a better visual, like the visual effect, basically, we can say visualization. So I have placed Bangalore, Chennai, Coimbatore, and Kochi. So these are my marketplaces. Now to locate my distribution channel, basically DC. Now it can be in the Bangalore. I can place it in Bangalore. So let me just take a pen. I can place it here, or I can place it here in Coimbatore, or I can place it here in Chennai, or I can place it in Kochi, or I can place it somewhere else. Okay, depending on the conditions, like seeing that if I distribute from this center to different marketplaces, how my the cost can be minimized, the transportation cost can be minimized. Okay, so I cannot take this decision without any calculation. I can only think that I can set up in Bangalore or Chennai or Coimbatore or Kochi, whichever is convenient in terms of reducing my transportation cost. Okay, so this is what we have to find out, the location of this DC, that where it should be. Okay, no questions, right? So just let's go further. Interesting, guys.
Yes, yes, it is interesting.
Okay. Now to do this, so first step is to define the objective. So what is your objective? Our objective here is to minimize total transportation cost from the new distribution center to each of the demand points, marketplaces. The transportation cost depends on distance from DC to each marketplace, the demand at each marketplace, the transportation cost per unit kilometer for each location. We need to find the coordinates, latitude and longitude for the new DC. As I said, that what is our goal? Our goal is to find the DC coordinates basically, wherein our transportation cost is minimum. This is the object. To minimize the total transportation cost and to find out the DC location basically. Okay, so this is our objective. Now the data is given, as we have seen, like we have gathered the input data. And see, you are seeing this data that I have put only 4 marketplaces. But if there is an Excel containing 1,000 marketplaces, then it will be very, very difficult even to, like even on the map, you will get a little bit frustrated to see that how, like you can actually move your things from DC to the different marketplaces. Okay, so this is kind of a condition I am talking in. So we are taking a very, very simple use case wherein we will see that how to build an optimization model. Okay. Now let's say, okay, so first then we have to define the variables basically. So X is the latitude of DC, Y is the longitude of DC. These are the variables we want to optimize to find the best location for the DC. Now let's say what is like, like if we call it as XDC, okay, and if I call it as YDC, okay, so in the like in geometry or like in coordinate geometry, how we will calculate the distance between a marketplace, say Xi and Yi. Okay, so distance can be calculated like this. Basically, your XDC minus Xi whole square plus YDC minus Yi whole square. Okay, and when you have 4 centers like this, basically you have to take for all the summation of all the 4. So basically here your I is from equal to your 0 to 4, and this is your distance basically, right? But in the when you talk about, like, because the earth is round, it is not a flat geometry, it is a round shape thing basically. It is round. So basically your this formula is little bit different here. So when you just take the formula of the distance from xdc to xi, this formula is little bit different. We have to calculate it with the, like, taking into account the arc's radius and the arc basically it will travel. And also, like, it won't be a straight distance. It is kind of, like, there can be a zigzag way, left and right and all these things. So there is an optimized formula for that. Like when we are talking about a spherical object, like moving on over a spherical object. Okay, so let's see what is the formula. So formula, before coming to the formula, this slide, I will come to this slide later. First, let's say what is our cost function then, because we are reducing our cost. So our cost function is demand into transportation cost per unit kilometer into distance, right? So what is the total distance? And multiplied by the transportation cost per unit kilometer. So distance here is the distance between the marketplace and the DC. Transportation cost per unit kilometer is given and multiplied by the demand. So this is your cost function. Now your total cost is definitely like how many demands and like the marketplaces you have. So I from 1 to n signifies that the number of marketplaces. So demand into transportation cost per unit per kilometer into distance from the DC to the marketplace. Okay. So this is your total cost. Now what is our objective here? Our objective is to minimize this TC. Minimize this TC. So to minimize this TC, what will be our TC location to get that coordinate X and Y? Okay. So before going to the even that demand formula, distance formula. So this is what my objective is, to minimize this total transportation cost. Any questions so far? Okay. So let's go back to the distance formula. So because the earth is round, so our distance formula is basically r into cos inverse. So r cos is nothing but the cos inverse sine of latitude I, cos of latitude I, and cos of longitude I. So this is basically a basic formula of calculating distance on a spherical object. So we here how we calculate our distance. Okay, so this is a formula for calculating distance. Now let's build this model. So basically I have written a Python code. I will just go back to the Visual Studio Code. So here actually you can build your model, right? So you can actually use this SciPy optimize library to build your model, and I have imported the minimize, basically the minimize library from here, SciPy optimize. Okay, and there is basically different kinds of optimization model you can build. Sometimes you can build the maximization factors, like like where you have to maximize the profit, but here we have to minimize our transportation cost. So I have feed in some data. So this is a very, like if you want this program, I can give you. So basically you are just running this model and you are just calculating your transportation cost. So while feeding all this data, the latitude, longitude data, and the demand data, even the transportation cost per, like per kilometer. So while feeding this to the model, we get this, like this result, wherein I can run this also. So this is my result. And this latitude, longitude, if you find in Google Map, it is very near to Bangalore or maybe the outskirts of Bangalore. So basically, you can put your DC safely in Bangalore location and with the minimized transportation cost as this. So this is what it is coming. Okay. So basically, you are checking that how you can minimize your transportation cost so that like you can set up your distribution channel over there, distribution center over there. So this is the X coordinate and Y coordinate which has come from the model where your transportation cost is the minimum. Okay. So this is how actually, like you can build the digital twins and you can calculate, like you can actually build different optimization model. And this is very, very useful in taking decision making. And if it is the data is very, very big, then optimization will become more and more complex. Like to calculate in a bare just with the bare visual effect, or like with bare calculation, it will be very very difficult. Even in the Excel you cannot do if there are multiple like this marketplace and distribution channels are there. So we can see in our next sessions that how you can build optimization model where you have number of like here we are seeing only one distribution channel where there are like n number of distribution channel will be there. Okay, so the last step is that when you have your coordinates and everything, you can just test with varying demands and cost per unit per kilometer. You can just test this model whether this is okay or not. You can run some sensitivity analysis to evaluate model stability under potential real world changes such as varying fuel price or seasonal demand fluctuations. So this thing you can do. Now the model give us this answer. So this is your optimized logistics, basically the distribution channel setup in Bangalore. So from Bangalore, you are actually delivering to Chennai, Coimbatore, and Kochi, and of course in Bangalore with the minimum transportation cost. So this is how a simple case study or a greenfield analysis you can do with the help of the optimization model in supply chain. Any question, guys?
Yeah, so not a question, just clarity I want is that the Haversine formula and this optimization algorithm, like we have learned it in operations research to optimize
Right.
different optimization.
Yes.
So,
There can be different formulas basically based on your use case.
so like these formulas and the optimization technique can be implemented in a PLM software, which will help eventually in decision making.
Sorry, Hariom, just repeat your question. What is the question?
As we have these different optimization algorithms for these
Right,
different scenarios.
right.
So in PLM software,
Hmm.
so these algorithms, the optimization will help us to do the informed decision making.
Yes, basically it will take give you different level decision making. It is not only about your setting up your distribution network, distribution capacity, but also kind of it can be like like demand forecasting. In the last session, we have seen on multicolor simulation that how we can actually like forecast the demand so that we have the break even profit. Like we don't have a profit either, we don't have profit or we don't have loss also. So how we can get that break even point with the demand forecasting, like simulation. So that is also a part of digital twin where you have the data, you are building a simulation mechanism where you can simulate and find out your, like the what is the objective you want to find out. Here we are finding out the cost, the transportation cost, and how to minimize that to get that exact location where from where if I am distributing, my transportation cost is minimum. Likewise, there can be different optimization use cases in supply chain where which you can take care given you have the proper data and you have the proper system and you have a control room.
Okay. Yeah, it's clear. Thank you.
Any other questions, guys? So if you need this program, so this program is a very small program. You can just have this. It is a very small case study. If you need this PPT and this program, and also the simulation, last session simulation, Excel, let me know. I will send you.
Uh, yeah, we need the PPT actually. Like, it has much information on supply chain management.
Okay, sure. Okay, so thanks, guys. This is all about the decision. Hope you gain some insights. Probably we will bring some more sessions on, like how to build some more complex optimization model or how to analyze more complex supply chain data.
Thank you.
Thank you so much. Have a great day, guys.
You too.